The introduction. Green building is now a major goal in Malaysia. Instead of using old methods, developers are using building eco-friendly projects to save energy, reduce waste, and protect the environment.
Assalamualaikum and good evening. Today I will be explaining about the type of a green building. First, we have a net zero ready energy building. These structures are designed to be highly efficient and are fully prepared to operate at a net zero energy once renewable sources are integrated down to the line. Second is a net zero energy building. Unlike the ready structure, this building already generate as much renewable energy directly on site as they consume over the course of an entire year. Then they are net zero carbon or zero carbon building, which is the main focus here is emission. These facilities are heavily dedicated to reducing and eliminating or completely offsetting their operational carbon emission. Last but not least, we have the Grid Interactive Zero Carbon Building. These are advanced structures that go a step further by actively managing their energy consumption and load in a direct coordination with the local electricity grid. Four distinct approaches, all working toward a more sustainable world. That's all for me. Hi, we are going to continue present to the green construction process. It all starts with the site selection and planning. In the first step, land sustainability is assessed based on the ecological factor like soil integrity, transit access, and the impact on the local biodiversity to prevent land degradation. Next is the design stage where professionals develop blueprint that dedicate the future energy footprint of the facility. They achieve this by integrating passive cooling, natural illumination, and high performance energy system into the building core design. Then comes the material selection and procurement. This is to reduce the embodied carbon. Sustainable resources like bamboo, recyclable metal, and non-toxic coating are carefully chosen based on their durability, recyclability, and the low environmental footprint. Once plant and material are ready, the construction phase begins. During this stage, contractor implement sustainable on-site practice, including the strict pollution control and meticulous waste management. This is to minimize the material loss and resource waste. After structural completion, we move to the testing and commissioning. This is where the building HVAC, lighting, and water system are verified to ensure they align with the rigorous green standard before anyone move in. Finally, we reach to the operation and maintenance stage. Even after the construction is finished, the building requires a consistent ongoing management to sustain a peak energy performance and excellent air quality over time. That is how a truly green building is made from start to the finish. Thank you. That's all from me.
Um, Green building are a sustainable material and advanced technology to reduce environmental impacts while improving building performance. Sustainable materials such as recycled steel, sustainable sources timber, precast concrete, low E glass, insulation, and low volt paints help conserve natural resources, reduce carbon emission, and provide a healthier indoor environment. In addition, green building incorporate technologies such as solar panels, LED lighting, smart HVAC system, rainwater harvesting system, and building management system or BMS. These technologies improve energy and water efficiency while reducing operating costs. Overall, the combination of sustainable material and innovative equipment create buildings that are environmental friendly, energy efficient, and more comfortable for occupants, making green building an important part of sustainable development. Next, I will explain the standard procedure of work in green building. The development of green building follow a series of carefully planned procedures to minimize environmental impacts. while maximizing resources efficient, occupant comfort, and long-term sustainability. Unlike conventional construction, green building considers sustainability throughout the entire building life cycle, from planning and design to construction, operation, and maintenance. The first procedure is sustainable planning and design. During this stage, architect, engineers, and project manager work together to assess the project environmental impacts. They carefully select suitable sites, optimize the building orientation for natural lighting and ventilation, and establish sustainability goals such as energy efficiency, water conservation, carbon reduction, and green building certification. Second procedure is the selection and procurement of sustainable material. Green building use environmentally friendly materials such as recycled steel, precast concrete, sustainable sources timber, recycled glass, and eco-friendly insulation. These materials are chosen based on their durability, recyclability, and low environmental impact wherever possible. Locally sourced materials are used to reduce transportation emission and support local industry. The third procedure is sustainable construction management. During construction, contractors implement waste management practice by reducing reuse and recycling materials. They also control dust, noise, water pollution, and soil erosion while using energy efficient machineries. Regular inspections are carried out to ensure that construction activities meet green building standards. The fourth procedure is the installation and commissioning of green technologies. This includes solar panels, rainwater harvesting system, energy efficient HVAC system, LED lighting, water saving system, and building management system. Before the building comes operational, these systems are tested to ensure they perform efficiently and achieve the intended sustainability goals. Finally, the last procedure is building, operation, and maintenance. Sustainability continues even after construction is completed. Building manager monitor energy and water consumption, indoor air quality, and system performance through smart technology. Overall, this procedure create buildings that are more energy efficient, environmentally responsible, energy effective, and sustainable while providing healthier environment.
Hi, my name is Muhammad Ghazi bin Muhammad Fuad. So I will present about the challenge and strategies to overcome the barriers. So first, we have lack of awareness. So even though this technology is not entirely new, the actual depth of knowledge amongst industry professionals remains very low because widespread educational exposure is missing. This gap leads to a poor understanding of green energy and a general hesitation to move away from conventional and traditional practice. Next, we have higher initial cost. So green building require a higher upfront investment because of the premium quality of sustainable materials and the technologies. Additionally, to execute these designs demands highly skilled labor, which raise construction costs. Next, developers are often burdened by the availability of supply and the transportation costs. So it's leaving them worried about profits since customers nowadays are primarily searching for low cost and affordable properties. And finally, we have gaps in policy and regulatory. So the regulation of green building practice in Malaysia is largely voluntary. So when policies are not legally mandated, project stakeholders tends to ignore them in favor of faster completion times and immediate capital gains. Without strict enforcement and pressure from the government, green tech integration is easily neglected. So next we have the strategies to overcome the challenge. First, we have publicity and educational programs. So the Construction Industry Development Board, CIDB, can leverage mobile and digital platforms to share the information about green building rapidly. So next is the educational programs. These programs must target developers, consultants, and developers to build professional capacity while in the same times educating the public about how green assets save money in the long run and provide a superior, healthier lifestyle. Next, we have financial support from government. Since 2020, regulatory bodies have offered financial relief such as the investment tax allowance and income tax exemption for project achieving a specific green benchmark scores. Expanding this initiative to include subsidies or low interest loans for contractors and developers, as well as residential end users, will stimulate the market demand and lower individual economic burdens. And finally, we have stricter policy enforcement. In alignment with the 13 Malaysian Plan that pushing toward a green economy, our codes should mandate minimum percentage of green materials and technologies in our construction work. Utilizing established rating system like the Green Building Index can actively push certificate promotion. So, as example, we can look to our neighbor country, Singapore. They successfully raised their baseline environmental standard by legally enforcing energy efficiency minimums.
Next, I will be presenting about Merdeka 118 building. For the background of the project, Merdeka 118 is a landmark mixed-use development located in Kuala Lumpur. The project was developed by Pemodalan Nasional Berhad or PNB through its subsidiary PNB Merdeka Ventures Sendirian Berhad. The construction began in 2014 and was complete in 2023, with the building officially opening in January 2024. Standing at 678.9 meters with 118 floors, Merdeka 118 is currently the tallest building in Malaysia and the Southeast Asia, and one of the tallest buildings in the world. The project was designed not only to celebrate Malaysia's Independence Day, but also support sustainable urban development by combining office space, hotels, retail areas, and public facilities into one integrated development. For the parties involved in completion of Merdeka 118 building, firstly, Pemodalan Nasional Berhad act as the project owner and financier, providing the investment and overall project direction. Secondly, PNB Merdeka Ventures Sendirian Berhad serve as the project developer and manager, overseeing the planning and execution of the development. The lead architect was Fender Katsalidis from Australia, who was responsible for the building iconic design, while RSP architect planner and engineers act as the local architecture consultant and design partner. For construction, the main contractor was a joint venture between Samsung C&T Corporation and UEM Group Berhad, which managed the construction works and coordinate the project on site. Finally, Leslie E. Robertson Associate was appointed as the structural design consultant, ensuring the building structural safety, stability, and ability to withstand wind and the loads. The collaboration between this organization was essential in delivering a complex and internationally recognized skyscraper like Merdeka 118.
Hello, so I will present to you about the types of design related to green building. For the first one is energy efficient architectural design. It uses a high performance low E titanium coated glass facade. It is reduced UV penetration and solar heat gain, maximize natural daylight while reducing indoor heat. Next is decreased dependence on air conditioning. And the last one is achieve up to 28% energy saving compared to conventional buildings. For the second one is active sustainable system. It is employ an integrated HVAC, which is heating, ventilation, and air conditioning system. It uses a chill water energy storage system connected to a district cooling plant. Next one is equipped with sun sensors and automatic blind controls. And features underfloor air conditioning for better air circulation. Lastly, it is improved energy efficiency and indoor comfort. And the last one is the rainwater harvesting system. It is to collect and store rainwater for reuse. Recycled water is used for toilet flushing and cooling tower operation. The last one is reduce dependence on treated water supply. It is achieved 43% water savings compared to conventional buildings. So let's move on to challenges during construction and the solution. The first challenge was structural stability. Since the tower is about 680 meters tall, strong wind could cause it to sway. To solve this, engineer designed a reinforced concrete core support by mega columns, outrigger, and belt trusses. This system works together to make the building stronger, reduce movement, and ensure the safety. For the second one is high performance concrete issues. The second challenge involved the concrete. The original C85 concrete was not enough strong for the building structural requirement. Engineers upgraded to C105 high performance concrete with basalt aggregate, giving it greater strength and durability to support the tower safely. For the third one is the concrete pumping at extreme height. It is another major challenge was pumping concrete to extreme height. Pumping concrete above 500 meters was difficult because of the high pressure involved. Engineers solved this by performing many pumping tests and carefully controlling the concrete mix to ensure it remained consistent and strong. For the fourth challenge is hot and humid climate. Malaysia's hot and humid climate was another challenge. High temperatures can affect the quality of fresh concrete. To overcome this, engineers use cooling cellulose and carefully control the concrete temperature throughout the pumping process, ensuring proper curing and strength. After that, fifth is the steel spire installation, which is 169 meters. The final challenge was installing the 169-meter steel spire. Since it was too tall and heavy for normal tower cranes, engineers used a strain jack system together with hydraulic lifting technology. This allowed them to lift the spire safely and accurately into its final position. So for the conclusion for this slide is constructing this super tall building required innovative engineering solutions. The project overcame challenges related to wind resistance, high strength concrete, extreme height concrete pumping, Malaysia's hot climate, and installation of the steel spire. This solution ensured the building was safe, stable, and durable during for a long term.
Next, the comparison similarities and differences with another building. For our comparison, we choose the Exchange 106 or known as a TRX in Kuala Lumpur. We choose TRX for a few simple reasons. The first one, both are iconic skyscraper that support Malaysia's economy and growth. Both use modern technology, strong foundation, reinforced concrete, and heavy cranes. Both of it need careful planning, great teamwork, and strict safety rules. Because of this, there are many interesting similarities and differences that we can analyze. Merdeka 118 and the TRX share so many similarities. For construction, both projects use IBS system to work faster, to improve quality and reduce on-site labor. Economically, both buildings help Malaysia by attracting investment, creating jobs and increasing properties values. Finally, because they are so tall, both mega projects face big engineering challenge and require strict safety management system to protect workers. There are also a few key differences between the two buildings. The first one, Merdeka 118, is a mixed-use building, while TRX 106 is mostly an office tower. The second one, Merdeka 118, is taller, making the construction process so much more complex. Finally, Merdeka 118 serves as a tourism landmark, and the TRX 106 focus on financial and business activities. Finally, in conclusion, green building is becoming very important in Malaysia with support from the government and GBI. Even though it faces challenges like high cost and low public awareness, but it brings a great long-term benefits and will help Malaysia achieve its net zero goals. Thank you.